guys, I just finished making this entire video, and let me tell you, I had an absolute blast getting this monitor back up and running. It's been running currently for 1 hour, and I have had 0 issues with it. So I consider this repair / modification a success. Basically what we're going to be doing today is taking a PC fan and just building it into the monitor. Now, that sounds simple, but it's not that simple. I had to make a ton of cutouts. I had to build a small circuit to coincide with the PC fan because I didn't want the full 5 volts at however many amps going to the PC fan because it was just too loud. So I went ahead and built a little circuit that would limit the current to the PC fan so it would quiet down just a bit. So there was quite a bit of work that went into this. So I had a lot of fun making this video, and I hope you guys enjoy watching it. Don't forget to leave a like, sit back, and enjoy. Hello and welcome to another installment of A Computers and Technology, and once again we're going to try something a little bit different today. As you can see, my desk is an absolute mess, and I'll show you what I'm working on in just a second. But today I'm actually going to be doing a repair on camera, which is something I don't do that much because it's already frustrating trying to get everything apart and put everything back together and get it back out and up and running without having to film it and doing all the video editing and uploading it afterwards. So I just try not to deal with that because it just makes things 10 times more frustrating. I'm already frustrated trying to, repair all this stuff, and doing the video on top of it is just, too much. But since it's Thanksgiving break and I do have a lot of time, I thought, what the heck, why don't I show you guys, what I do? And I am a learning electronics student. That being said, I haven't taken any classes related to my majors. It's just all been gen eds, which is really annoying. So I'm self-taught up to this point, so if you see anything wrong in this video, and this is what I love about YouTube, it has an awesome community behind it, especially my channel. If I say anything wrong or use the wrong terminology, please correct me, because I am learning, and I really like when people come along and try to help me out with my education here. Well, what exactly are we fixing today? I'll show you the problem in just a minute. I have like a hodgepodge of clips on this camera because today's just been a complete mess, so I'm going to have to find some way to edit them into one smooth video, so that's going to be really interesting to see if I can even do that. But this Dell monitor right here, and of course, as I said, I'll bring it out in a minute and actually show you the problem. And trust me, you'll probably be tired with this monitor by the time we get done with it because it's going to be on camera for most of the time. But this monitor, for some reason, the LCD will just black out, let's say after 2 or 3 hours of operation. It really depends on what the temperature is in here. And I think it's a heat problem. So that's why there's a fan right here. I'm going to try to add this fan to the actual monitor. Now, throughout the day, I've been going through different solutions with this, and I've come up with just using the 5 volts USB from a USB port on the computer or near the computer to power a fan. Now, there is a small circuit involved with this because I don't want the fan to be too noisy because that's really annoying. It's right next to my head. I don't want to hear the fan the whole time because it just gets really aggravating. I'm sure some of you can understand that. So what I originally planned to do was to take this monitor apart and probe around and see if I could find some reasonable voltage output that I could use to power the fan. Pretty much everything in there is high voltage, and I started probing around and I realized this is really stupid. I'm going to hurt myself. So I put it back together and tried to come up with a different approach. And of course, I'll talk about these approaches in greater depth when I get over here with the camera and start showing you guys what the heck I am doing right here. But the first approach, as I just said, was going into the monitor and seeing if I could just find a reasonable voltage output. Unfortunately, this doesn't have built-in USB because I could just wire the fan up to that. So that's really unfortunate. Next, I plan to use a 10-volt power supply, which has since disappeared somewhere in the room. But the thing is, it was just too big and bulky, and I could not find a way to fit it inside this case. So I scrapped that after trying to figure out what I was going to do with that for like 2 hours. And then now I'm here. With this USB cable, and we're just going to hook it up and have it run off the 5 volts from the USB port. And of course, as I said, we have a small circuit, which is basically just 2 resistors and 1 capacitor. And if you're wondering what this is, well, this is going to be our circuit board. And some of you are probably screaming right now, and I'll tell you why this is going to be our circuit board in just a second. So right now I'm trying to get that failure to happen on camera so you guys can actually see what's going on here. So I went ahead and cranked the brightness and contrast all the way up to get it to happen a bit quicker because on the settings that I have, it actually lasts for a couple hours before the LCD shuts off. And actually what happens is the LCD shuts off, as I just said, but the monitor itself will remain on. So this power light right here will remain green, and then power to the USB ports and everything else will still be there, but the LCD itself will be black and actually shut off. Not just black, but completely powered off, which is really weird. And it's a result of something overheating in the monitor. We're going to take this apart, hopefully, if I can get it apart, because it's held together by like clips on the side. So I've never taken one of these apart. I've taken a couple different Dell monitors apart, but not this particular model, so that'll be interesting. It's always fun to try to get these apart because they're just an absolute pain. Alright, so the thing finally died. As you can see, the monitor is still powered on, but the LCD itself is shut off, and it has gotten pretty hot. So I'm going to see if I can duplicate it actually shutting off. I'm going to turn it off. Wait just a couple seconds and turn back on, and it should shut off immediately after I turn it back on. Come on. Alright, let's see. Alright, there we go. I finally got it. I just left the camera on the table next to the monitor because I was going to go grab a tripod, but thank goodness I didn't turn the camera off because it did just happen.
And let me cut in here. I was actually watching this clip while editing the video, and it appears that there is a faint image on the LCD. So initially I thought both the LCD and the backlight were failing at the same time, but it appears that is not the case. I think the backlight is just failing because I can still see the image on the screen, and I think I might try to duplicate this, but if I shine a light on the LCD panel, we should be able to see the image. I'm not sure if I'm going to do that or not.
So that's what it looks like when it actually shuts off. So I'm not sure if that's a safety feature built into the monitor. If it gets too hot, it shuts that off, or maybe it's a bad solder joint somewhere, or maybe its voltage regulation is failing at some point. It might be a problem with the power supply. So there's a multitude of things that could be wrong with this. So we're going to have to open this up and actually go inside and see what's up. What I really want to do with this is just take a basic PC fan, find a 12-volt supply in here, or something close to that, solder the PC fan connector to that, and just have a small PC fan blowing air into the side of the monitor. Because when it shuts off, I usually just take this red, I'm not sure if you can see it on camera, but I take this fan and just put it right up against the side of the monitor and have it blow air across it, and it will stay on as long as I have the fan on next to it. So that's one solution. Another solution that I saw online is you can actually take a capacitor, put it over a resistor, bypass that resistor with the capacitor, and half of the display will shut off. So the other half will be on, but that's really stupid. I don't see that as a fix. I want the entire backlight to stay on. As you can see, I've been doing a little bit of post-Thanksgiving tinkering. I originally planned to use this 10-volt power supply to power this 12-volt PC fan. But when I initially tried to do that, it was a little bit too loud. I knew I wouldn't be able to stand that in the monitor right here because it's right in front of my face. So I grabbed some resistors, put them in series with the power supply and the fan, and it did quiet it down a little bit. But then again, I thought some more about it, and it would just be an absolute pain to fit this brick inside the monitor, along with that little resistor series we have right there, and the fan. So it's just taking up a little bit too much space. So then I decided just to use the 5-volt DC from a USB port, and probably that exact USB port right there. But when I placed it on 5 volts, the fan was still just a little bit too noisy, and I can actually demonstrate that right now. Let me go ahead and crank this up to 5 volts. Okay, we could go to 4.9. That'll be fine. And I'm going to go ahead and start the fan. And I'm not sure how well you can hear that on camera, but I can hear it, and it would just be annoying with that right in front of my face all day. So I grabbed some resistors, once again put in series with the circuit, and let me go ahead and focus that. You can see I have 2 resistors in series. These are both 4.7. Oh no, this is 4.7 ohms right here, and this is 1. Gosh, what is this? 1.5 ohms, so 4.7 ohm resistor and a 1.5 ohm resistor in series, and then that quiets it down just a little bit. Yeah, I can't get them to contact. There we go. Alright, yeah, so that's a lot quieter than before. And you can see that the fan is actually consuming 0.16 amps. So I'm going to work on this tiny little circuit, not even a circuit, it's just really a series of resistors, a little bit more, and see if I can get it to perform just a bit better The fan's not starting up too well, so I might have to put a capacitor in parallel with this just to get it to start up a bit smoother. So I'm going to tinker around with this a little. Alright, so I went ahead and put a capacitor in parallel with this tiny little circuit to help jump the motor because it's using too much current. It should be using 0.16 amps. That's definitely not right. So I'm going to go ahead and demonstrate what it looks like with the capacitor in parallel with this. You can actually see we're using the proper amount of current now. There we go. 0.12 is really what it should be at. Because I was testing it at higher voltages earlier and it was hitting that. So it was weird that when I went down to 4.9, that was sitting at 0.16 amps. That didn't seem right. So yeah, that little capacitor helping jump the motor is definitely going into this tiny little circuit. And just to satisfy my curiosity, I might throw this clip in there. I'm going to start the motor with the capacitor in parallel and then take it out. So this is with the capacitor. And now I'm going to go ahead and quickly on camera, I'm just going to go ahead and pull the capacitor out. Ooh, can I get a good angle? Kind of. So I'm going to knock the capacitor out, pull it out from these resistors. There we go. Capacitor is out. Just going to place the resistors back in here. And this is what it looks like running without that capacitor. So it didn't spin up to as high as an RPM as it did with the capacitor in parallel because the capacitor is initially jumping it. And you can see that we are actually consuming 0.16 amps. So yeah, as I said earlier, capacitor's going in there. Okay, so this clip's mainly going to be to keep myself on track, so when I get up tomorrow I actually remember what I'm going to do, but I could not find any PCB material laying around. I looked at a couple power supplies, but there wasn't much to work with as far as cutting it out and reusing it again, which you can do, but yeah, there just wasn't enough to make a very, very, very tiny printed circuit board. I guess it would just be a circuit board because there's not going to be anything really printed on it, but we're going to have a really interesting botch job tomorrow because I was thinking about, you know, what could I make this little circuit board out of? And I found this little wrist rest, which I'm never ever going to use. So what I think I'm going to do, which some of you are probably going to absolutely dread, and this isn't going to be, you know, super safe or anything, but what I'm going to do is take this, put a Dremel to it, and cut out probably a 3x3 square of plastic. And then on that plastic, I'm going to drill a couple holes so we can put the two resistors in, drill 2 holes for the capacitor, and then have traces all along. Well, I guess this side would actually be the best side to have the traces, but we're going to have traces all along the bottom of this. So I'm curious to see what the melting point of this plastic is, because if it's too low, the soldering iron and the solder is actually going to go through it if I'm not careful. So we'll test that out tomorrow. But once again, going to be a really interesting job. I'm also going to build in a rocker switch to the monitor, but we'll get to that when I actually start taking the monitor apart, which I already have taken it apart, and it is an absolute pain. I don't know why I just didn't leave it disassembled. But anyway, that is a job for tomorrow. I will see you guys when I get up. Oh yeah, also I found a USB cable that we're going to use, although I don't think it's going to be long enough, so I'm going to have to make some modifications to it. I was afraid I was going to have to drive out to the dollar store and buy one, which, you know, doesn't take that much work. What really makes me angry is that the Radio Shack, even though they're really overpriced, but it's convenient to have a supply store around like that, the Radio Shack closed, so, you know, obviously I couldn't buy the PCB material I needed, or the shrink wrap tubing that I needed, so I'm going to have to order that online, and I'm not going to be able to use it for this project. But for this USB cable, you can see that the end has this little connector to it, which we're just going to cut off. This was actually meant to go into the a socket on a motherboard, and this was actually used to connect some kind of external drive. So I'm going to cut this off. Obviously, we don't need all those wires, just the one for the 5 volts from the USB, so we can cut off all the wires for data transfer. I'm probably going to need to make this thing longer as well. So it is the next morning, and I've started cutting that piece of plastic out, and then I figured that 1x1 would be a better option because I measured out 3x3 and it was just gigantic, and the whole point of this was to try to keep it somewhat compact. Of course, I only have one blade for the Dremel. We didn't buy any more. I looked around and this was the only thing I could find, so I'd rather you know, there'd be a circular saw attachment, but I think this will work just fine. So I already tried cutting it and it did pretty well. So let's finish this off. The smell of burning plastic in the morning, and I gotta cut this little side piece off right here. I'm gonna get something to hold this down because that's gonna be a little bit dangerous. Alright, so this is what we're going to be using, a very, very small piece of plastic, because we only have to fit 3 components on here, the 2 resistors and then the capacitor, and then of course the traces have to go through here, so the smaller the better as far as that goes. I'm going to sand down the edges a little bit because it is still, well, a little bit rough around the edges, and then we'll get back over and try to build the circuit on this, the tiny little circuit for the fan. Alright, as you can see, I also went ahead and drilled out the holes. There's our 2 resistors in series, and then the capacitor is going to go in parallel right here. You know, I routed that out kind of funny. I knew what I was doing when I drilled it out, and now I'm not so sure. But anyway, we'll take a look at this. I'm going to go back inside and try to mount everything on here. You know what? I just realized I did drill out the holes wrong. I must have had a brain fart there for a minute. Because initially I knew what I was going to do. I should have drawn it down on something and had it in front of me while I was drilling. That would have been the smart thing to do. But instead of having 2 inputs going in and 2 outputs coming out on each side, there's going to be 1 input and 1 output on each side. So I mean, I understand how it works, so it's not too bad for me. But if anyone tries to service this, which I doubt they will, it's going to be extremely confusing for them because it's not really practical. So now I'm going to clear all this off, solder this together, and then test it on the 5 volts from the power supply. Alright, so this is what we have, and of course it didn't work out as well as I hoped it would. I thought the solder would actually stick to the plastic a little bit, but it didn't stick at all, so now it's just a mess of wires, because I wanted to trace it out like I would on an actual printed circuit board, like just take the trace and drag it through. Yeah, but I couldn't do that because it wasn't sticking to the actual plastic. So yeah, I just grabbed a bunch of leads that I had laying around, and as you can see, I just soldered them to the board. Really sloppy, really unsafe. Especially right here, these wires are really close. I'm going to get some hot glue and glue those down. But it should serve its purpose. So I'm going to go ahead and plug it in and hopefully it doesn't blow up. And I actually did get the inputs and outputs to go on the same time with a little bit of switching around there. Switched a couple components around and got it so the input comes in here and then the output goes out here. And this is, what is this? This is the positive terminal and negative terminal right here because we don't want to blow up that capacitor. Alright, so I have it hooked up to the DC power supply right now, outputting 5 volts. Let me get the camera over here. And it's doing pretty well. Haven't had any issues yet. So I'm going to leave this running for probably about an hour just to give it a somewhat long-term test. I'm going to glue the components on to ensure nothing shorts out, you know, after I put it inside the monitor. And then we'll actually get to opening up the monitor and making the modifications that we need to hook it up to the USB. And of course get that rocker switch in there too. Been running for 15 minutes right now. Nothing's really gone hot at this point, so let's go ahead and mess around with this because the max voltage of this capacitor I think is 16 volts, so I should be fine just messing around with this little power supply right here. So let's jump the voltage a little bit. Put it back to 5. Oh, I got it exactly at 5. Awesome. All right, and what does that feel like? No, nothing's getting too warm yet. All right, so it passed the 1-hour test. I'm going to go ahead and hot glue all of these components down. Okay, so the top doesn't look too bad. All I did was take some hot glue and put it under this capacitor so it doesn't go anywhere. But under here, I'll get ready for it. Oh my god, that looks incredibly sketchy. I'm going to hook it back up to my power supply and make sure it still works. This is actually supposed to make it safer, but in the end, I mean, it looks really scary. Alright, so far so good. I'm testing it one last time before we actually try to put this thing into the monitor. I'm also going to test it inside the monitor with the power switch wired in, and the fan actually either glued into the monitor or I'm going to use zip ties. Haven't decided yet, but I'm just going to give it a couple bumps on the voltage just to make sure it can handle it. Alright, and I think it's ready to go. Okay, so this is the fun part, actually trying to crack into this monitor, and as I said earlier, I did take this apart already to try and repair it, and of course I put it back together, which was so stupid. I don't know why I did that. But the good thing is I actually have all the screws out. There's only 4 screws in all right here. I'll show you guys in a minute if anyone's here to actually see how to disassemble this thing. So just push this button, you want to pull the stand out, toss it over there. You can see, oh, you know, what are those screws to? Because I have no idea. Anyway, the screws are actually still in here. So I'm going to have to remove all 4 of these screws. I have some extra screws from something right here. That's weird. But I'm going to go ahead and remove these. And then after that, it's just a series of clips all around the monitor bezel. And I absolutely hate trying to deal with unclipping these clips around the bezel. Alright, so with the screws removed, next we have to start going after those clips that's holding this thing together. Nothing else is holding it together at this point. Alright, so after you have all the clips removed, do not try to remove the front of the monitor bezel because the buttons for the volume control and power are all still wired in by a ribbon cable. And if you try to rip it off, you will tear that ribbon cable, and that's pretty much into the story. Well, not really, but then you got to deal with putting that tiny little ribbon cable back together, and that's just another nightmare. So instead of doing that, you want to flip it over on the face of the monitor and just pull the back panel off. And it comes right off. And this is... I went deeper in here, but really this is all we need for this little modification. And you also saw that while I was actually prying the bezel apart that I put a pillow over the actual screen, and that's because my screwdriver slipped and put a tiny little scratch in the screen, and I didn't want that to happen again. So when you're actually doing this, I would go ahead and just put a small sheet over it just to protect the monitor while you're working around it. With a monitor like this, I have to remember that pretty much everything's backwards from this point because of the way that we have it flipped over. If we had it flipped this way, that would be the right way around. So I want the air to come in here because there's actually holes on the side of the monitor. Let me grab the camera and show you guys. There's actually holes on this side of the monitor, no holes on this side of the monitor. And I don't want the air blowing down through the top of the monitor because heat rises and that seems counterproductive. I want it to push the heat up. And hopefully, I think there might be 1 or 2 holes here, and hopefully out and across everything right here. And then the fan itself and the power supply and that USB cable are all going to go on. Let me grab the fan and that tiny little power supply right here. They're all going to go on, I guess it would be this side of the monitor. So I'm going to zip tie this in here. Our little circuit will go in just right here. I'll probably just hot glue it in, and I'm going to have that USB cable running out the other side of the monitor. And as I said earlier, I'm going to need to make this just a tad bit longer so it can reach the USB ports. Alright, quick update. I have to leave again, so once again, this is something to keep me on track as well. But first thing I have to do is extend this USB cord. So I'm going to add some of this, it's obviously heavier gauge wire than the original USB cables, and it's actually going to be a pain in the butt to strip these because they're just so thin. I don't know how I'm going to get the rubber off them. But I have to solder these together, make that a bit longer, and I'll just run it out the side of the monitor. That's not the big deal. What is going to be a big deal is trying to get this rocker switch wired in with our tiny little circuit. And in order to do that, I had to find a way to get this to stay inside the hole I'm going to make right here. And I'm actually going to drill this out, so that's another hard part. I'm going to grab the drill and probably just drill maybe a 1/6 of an inch out of this little flap right here. You see this grill? I might just cut one of these out and then put the rocker in between those and then just hot glue it in. I'm going to use a lot of hot glue for this project because not really a big deal to me how it looks because this is the back of the monitor. I'm never going to see it. Alright, so I am getting there. I did run into an issue. I accidentally used one of the data transfer cables as part of the 5-volt DC output, and then I hooked it up and nothing happened because it wasn't getting the 5 volts DC. I was actually outputting 1 volt, which was weird. I don't know why I was doing that. But now if I hook up the output from the USB port, which I have plugged in now, you can go ahead and see that it is functional. Just give me a second. There we go.
If you haven't noticed already, I decided to go ahead and make a cutout in the case to put the PC fan in. Now, my original idea was to zip tie the PC fan inside the case, but when I tried to close the case, there just wasn't enough clearance and I couldn't get the thing to close. So the easiest thing to do for me was just to make a pretty large cutout. It really wasn't that bad though, because the cutting and the measurements only took me about 5 minutes, so not that much more time added onto this at all.
Alright, so I'm about ready to throw the monitor back together and run it through a long-term test to see if it actually solves the problem. And I think this really should, actually. But I went ahead and fixed the USB cable issue, so that's all sorted out now. Unfortunately, I ran out of shrink wrap, so I had to get kind of creative there with the hot glue. There's just hot glue all over this thing. So one, I don't have some of the proper components, and two, it's just easy to use hot glue. Man, you can see in here, I mean, it's not horrible, but it's not pretty at the same time. Once again, it will get the job done. You can see the circuit board mounted here with some hot glue. Once again, fan. Now, actually fits snugly inside the little square that I drilled out, but still I put some hot glue in there, so nothing can really punch it out. I tried to hot glue all of the stray wires and leads off so it doesn't short out or anything. And as you can see, hot glue all around this wire right here so it doesn't, just flop around freely inside the monitor. And you can see I used a big glob here to serve as tension release, so if someone yanks on the USB cable right here, it just doesn't, pull everything out, because that would really suck. And then on the front, or I guess this would be the back, you can see that I took these little spokes that I cut out of the monitor and just put them in front of the fan. So, if I accidentally reach for the power button, which I went ahead and installed right here, I don't, shove my hand inside the fan and not cut my fingers off because it doesn't have enough power, but I guess injure myself. So let's go ahead and test this out. It is currently off now. I have it plugged into that USB port over there, and we will see if it works. And there you go, and it's actually nice and quiet too. I won't notice this over my system when it's running, so not too worried about it. Definitely needed that tiny little circuit in there. It's doing its job, and it's doing its job well. So once again, I'm going to turn this thing off. And back on. Okay, so everything looks like it is working fine. I'm going to throw the monitor back together and test it out. Okay, as you can see, the monitor is back in my setup. It is currently powered on. Brightness is set to 100% along with contrast, and the fan is on the back here running away, blowing that nice cool air across the power supply, logic board, and inverter board. So we should not have any more issues with this monitor. After I went off camera, I did run into two problems. One, the wire wasn't sitting quite low enough below the actual metal shielding, so I couldn't close the monitor bezel all the way, so I had to do a little bit more drilling, and then even after that I had the wire run diagonally across down here. I don't remember exactly how I routed it, but it is making contact with the back of the bezel right here and the back of that metal shielding, so it was hard to close the monitor. And as you can see, the sides are bulging out at an oh so slight angle. It's really not noticeable, but I did have to use a slight amount of force to get this bezel back together, because that wire was adding probably maybe an extra eighth of an inch onto the back. And while I'm testing the monitor, I'm gonna have to clean up all of this garbage I've thrown around everywhere. And that's a bit better. Alright, so it's been about 30 minutes and everything seems to be working just fine, and of course it smells like glue in here, so I've opened up a window and turned the fan on, trying to air this place out before I go to bed, because that's the last thing I want to go to sleep to is the smell of burning glue. That's always wonderful. So I think that's going to be about it for this installment of AA Computers and Technology. I had a lot of fun for that little modification. It was kind of a pain as well. I got up at 9 o'clock in the morning hoping I would finish it by 12, and currently it's nearly 12 o'clock at night, so I just got sidetracked and had other things to do. So in the end, it was a lot of work, but I think the results are pretty good. Of course, I'll go into the comments section, leave a comment on how long I can get this thing to run without shutting off, if it ever shuts off at all, and I'm really looking forward to editing this video tonight and getting it out tomorrow. So if you have any questions, comments, or concerns, you can go ahead and post a comment in the comment section. Once again, if I used wrong terminology or you saw something funny in the video, go ahead and feel free to correct it. Don't forget to give this video a thumbs up, and please do not forget to subscribe to my YouTube channel. I'll see you guys in the next installment of AA Computers and Technology.